All right, everyone. In this video, we will be covering Lesson 5 and Booklet 12. That is simplifying across the equal sign and then solving. So similar to Lesson 4, we are going to be solving for the variable, and we are also going to be simplifying first. Now, this lesson increases the difficulty a little bit because in the previous lesson, you might have had two terms with a variable, but they were on the same side of the equal sign. In this lesson, you are going to find that you have some of your variables on the left-hand side and some on the right-hand side of the equal sign. So we need a way to manage that. Now, technically, you already have the tools to manage that. We are going to use opposite operations. But sit tight because it can get quite a bit trickier. So, your goal when simplifying is to take all of your terms with a variable to one side of the equal sign and all of your terms without a variable to the other. We're trying to separate them. Now, quick refresher, when I say the word term, I mean a set of numbers and or variables that are separated by a plus or a minus sign. So in this first statement, I have three different terms as labeled on the screen. Now, our goal is to have both of our terms with the v on the same side of the equal sign. So that's term 1 and term 3. They need to be on the same side of the equal sign. So we're going to take this entire thing and we're going to bring it over. How do we go about doing that? We need to use opposite operations. Now, this is the part that's going to be a little bit challenging. So if you need help, come see me and we can walk through it one-on-one, but I'll do my best to explain it here. We don't want to just move this 4. We want to move the 4 and the v. We want to move this entire statement. Okay? Now, in order to do that, we think, okay, that 4v, how is it attached to the rest of the equation? Again, I'm not separating the 4 from the v. They're staying together. Right now, they're a package deal. I want to take this entire thing and move it over. So I say, okay, the opposite of minus 4v is adding 4v, because the opposite of subtraction is addition. So let's take a look at what happens when I add 4 times v. I'm going to rewrite this entire thing because I also need to add 4v to the left-hand side. Whatever I do to the left, I do to the right, and vice versa. So we have 2v plus 4v is equal to 12 minus 4v plus 4v. So effectively, what's happening here is these two statements, they disappear. Minus 4v plus 4v. Let's use a different color for that. If I add and subtract the exact same thing, they're going to cancel each other out. So those disappear. And I'm left with 2v plus 4v is equal to 12. So by using opposite operations, I've rewritten the original statement, but now the two terms that have the variable in them, they're on the same side of the equal sign. And the only term that doesn't have a variable, that's separated. That's on the right-hand side of the equal sign. So step 1, take all of your terms with a variable, move it to one side, and then take all of your terms without a variable, move it to the other. And now you can handle this as if it was our problem from the previous lesson. Right? 2v and 4v, those are like terms. So we can add their coefficients. 2 plus 4 is 6. So 6v is equal to 12. Now, we're trying to isolate for v, so that 6 needs to get out of here. 6 is attached to the variable through multiplication, and the opposite of multiplication is division, so we're going to divide by 6. That cancels out, and we're left with v equals 12 divided by 6, or v is equal to 2. So the answer should be that v is equal to 2. Let's check and see if that's correct. Now, let's go back to our original statement, which was that 2v is equal to 12 minus 4v. And we are going to see if this is correct when v is equal to 2. So anywhere you see a v, instead, we're going to write a 2 in brackets. Multiplication first. On the left-hand side, we have 2 times 2, which is 4. On the right-hand side, we have 12 minus 4 times 2, so that becomes 12 minus 8, because 4 times 2 is 8. So 4 equals 12 minus 8 is 4, and the left-hand side is equal to the right-hand side, so we're done. So the answer is v equals 2. Hopefully that makes sense. We're going to do a couple more examples before this video is over. Now, let's take a look at example A, 6g minus 2 plus 3g. Wow. Let me try that one more time. 6g minus 2 is equal to 3g plus 10. So, again, our goal is to take any term with a variable, and we're going to bring those together on one side, and then we're going to grab any term without a variable, and we're going to bring those to the right-hand side. So I'm going to take this one step at a time. I'm going to take this one real slow, and then in the next example, I'm going to try speeding it up a little bit, and you can do the same if you're comfortable doing so. The first thing that I'm going to do is I'm going to take this 3g and I'm going to move it to the left-hand side. How do I go about doing that? Opposite operations. In order to move the 3g over, I am going to subtract 3g from both sides. Right? Because 3g minus 3g, that's going to cancel out. That's the opposite operation. So, in other words, I'm going to write 6g minus 2 minus 3g is equal to 3g minus 3g plus 10. Okay? If you prefer, you could write this as 3g plus 10 minus 3g. The order doesn't make a difference. But what you need to understand is that these two terms are going to cancel out. Okay? 3g minus 3g is 0, so those are going to go away, and that's going to leave me with 6g minus 2 minus 3g is equal to 10. Now, this 2, that doesn't have a variable, right? So I need to take the 2 and I need to move it over to the right. Right? Our terms without a variable go to the right. So I'm going to do the opposite of subtracting 2. I'm going to add 2 to this side, and I'm going to add 2 to this side as well. So, in other words, negative 2 plus 2, those are going to cancel each other out, and I am going to be left with 6g minus 3g is equal to 10 plus 2. So using opposite operations, I brought the 3g over to the left-hand side and it became negative 3g. And I brought the negative 2 over to the right-hand side and it became positive 2. And now all of our variables are on one side and all the terms without a variable are on another. Now we can collect like terms, right? On the left-hand side, we have two like terms. Their variable is g to the power of the same exponent, which is 1. And that means that we can subtract them. 6 minus 3 is 3, so we get 3g equals 10 plus 2, which is 12. Now, using opposite operations, we're going to divide this by 3. We're going to divide this by 3, and we get that g is equal to 4. So the answer is that g is equal to 4. I'm not going to check this one because we've run out of space on the page. But if I have room, I'll check the next answer, okay? But trust me, the answer is g equals 4. Now, this next problem, I'm going to focus on efficiency, okay? So instead of really drawing it out step by step, I'm going to be a little bit faster, use less steps. If you're comfortable, you can do the same, but if you need to, do it the long way. There's no rush. Now here, I have two terms with a t, that's negative 3t on the left and negative 4t on the right. And I have two terms without a t, that's 3 on the left, 12 on the right. So I'm going to move everything that's red to the left, and I'm going to move everything that's blue to the right. Now that requires two steps. Okay. First of all, this negative 3t, we need to get rid of it. We need to move it to the left-hand side of the equal sign. So I'm going to do the opposite. The opposite of subtracting 3t is adding 3t. So I'm going to plus 3t to the right, and I'm going to add 3t to the left. Now, at the same time, I need to get rid of this plus 3, right? So what I'm going to do is I am going to subtract 3 from the left and also subtract 3 from the right. So let's take a look at what's going to happen here, okay? This negative 3t plus 3t, those are going to cancel out. This plus 3 minus 3, those are going to cancel out. So what I'm left with is negative 4t, and then we have the plus 3t on the left that came here, is equal to 12, and then we have the minus 3 that is now on the right. Again, if doing all of that in one step is a lot, then take multiple steps like we did on the left. But if you're comfortable, you can do that all in one step. And now we can collect like terms. Negative 4t plus 3t, that's negative 4 plus 3, negative 1t is equal to 12 minus 3, which is 9. Good. So we need to isolate for t, so this negative 1, it's in the way. We're going to do the opposite. We're going to divide negative 1 from the left, and we're going to divide negative 1 from the right. These are going to cancel out, leaving me with t equals, what's 9 divided by negative 1? Well, 9 divided by 1 is 9. That doesn't change. But we have one positive, one negative. Our answer is negative. So t is equal to negative 9. Right? Why don't we check that because we have the room to do so? So our original statement is negative 4t plus 3 is equal to 12 minus 3t. But we believe that t is negative 9. So let's take negative 9. Let's plug that in everywhere we see a t. And let's math it out. Well, -4 times -9, ooh, you might need to use your multiplication chart for that one, but it will equal positive, because two negatives make a positive, it will equal positive 36. So we get 36 plus 3 is equal to 12. -3 times -9, well, two negatives make a positive, and 3 times 9 is 27. Let's continue. We have 36 plus 3, which is 39, is equal to 12 plus 27, which is also going to be 39. So the left-hand side is equal to the right-hand side, and the answer is, in fact, -9. All right. This one is quite tricky. I would say this is the hardest lesson that we've done so far in this course. So take your time and make sure that you're asking questions, but definitely practice with the following worksheet. Oh, there's 2 pages to the worksheet. That's nice. Make sure you're practicing with that, okay? Thank you.